If it's cotangent of x, is negative cosecant square of x. If it's secant of x, it's secant of x times tangent of x, or the derivative. And the last one, cosecant of x, the derivative is negative cosecant of x times cotangent of x. Okay? So there are 6 rules. The good thing about this is that, like I told you yesterday, these are going to be in the formulary, so you can use that. But remember that you have to use them. That's the difficult part. Not memorizing them, use them. Okay? Tell me when you're ready so I can start the example. Up until today, we're doing 14. And then on Monday, we'll send you one, that's the 15th. And on Tuesday, another one will be 16. Yeah.
Yeah?
Kind of.
Okay.
¿Cuántos son?
Como más de 16.
We'll see. Good. No. Well, if you consider the ones from Mat 4 and Mat 3, then perhaps. But no, derivatives 16, 17, perhaps.
Con eso quieren más.
Yeah. Okay. Can I start? Okay, fine. Example, number 1, it says y equal to 5 cosine of x plus secant of x over 2. As we seen yesterday, you have an addition here. You have an addition, is the derivative of the first plus the derivative of the second. Do I need to rewrite anything here? Rewrite? Well, the first one, no need to be rewritten. Okay, but the second one, perhaps you get confused by the 2. You can put that as, well, 5 cosine of x, and then that 2 is actually 1/2. So it's 1/2 secant of x. So if you don't see it, you can rewrite it there. Now, the derivative. Y prime is equal to what? 5 is the coefficient, so we leave it. And then cosine is going to be negative sign. So that's my derivative for cosine. Plus coefficient 1/2 secant derivative is what? Secant x times tangent of x. Can I simplify or rewrite anything from there? The minus. No. In this case, no, because they're multiplied. The minus will be minus 5 sine of x, and the other one is just 1/2 secant tan. Okay? That's the derivative.
So if you put that in the calculator, you can answer.
Calculator? Why? What for? It's a function. So it's a function. If you want to get the slope of the tangent line, you need the value to put it in the calculator and then solve it. But that will be for a different kind of exercise.
We're going to graph.
No.
Profe, entonces,
In theory, yeah. But it's very complicated. But no. Good. Next one. F of x equal to 10x to the cube minus 3 cotangent of x. We're combining things. We're combining algebraic, the power rule, and the cotangent rule. Do I need to rewrite anything here? No. No, in this case, no. Why not? Because you can solve this directly with the power rule from yesterday, and you can solve this cotangent with those rules.
30x cuadrado.
Yes. F prime of x is going to be 30x squared. Very good. Why 30? Because the 10 stays, the x to the cube becomes 3x squared. So it's 30. Minus 3 cotangent derivative cosecant square of x. Simplify, well, this times this will be positive, so 30x squared plus 3 cosecant square of x. Yeah? I just apply the rules directly. Now, what about number 3? Number 3, if you observe, you have sine square of x plus cosine square of x over 3 cosecant. There is no room for sine square. It's just for sine, not for sine square. So there's no room for that. Yes, exactly. In this case, for example, since there are no rules for this directly, you need to simplify it before finding the derivative. By using what? Identities. Very good. Trigonometric identities from last semester.
Oh my god.
Yes.
Identities. Ese es igual a 1.
Yes, exactly. No, no. Some of them. No, you cannot try that. Okay. So, yeah, sine square of x plus cosine square of x is a formula, so it's 1 over 3 cosecant. But the cosecant is in the denominator. I don't want that. So I need to use another formula. 1 over cosecant is what? You leave the 1 there, but the cosecant in the denominator becomes sine. Whoa. Yeah, same thing. You just put it like that, it goes solve this, but you can put it over 3 and it's fine.
That is identity.
Yeah. From here, this is a formula. And then from this, no. To this, the formula. This is not my answer yet. This is just the same function but simplified. Now derivative, now it's easier. So derivative g prime of x is going to be 1/3 cosine of x. And that's the answer. Okay?
Profe, y en el formulario va a venir lo de sin cuadrados, nuestros cuadrados igual a 1.
Some of them, but not all of them.
Also, en el formulario va a estar con identidades.
Not all of them. Okay. Fine. Listen. In case you forgot them, okay, let's try to. Well, I'll give you the formulas again. Okay, so you can remember them. Remember that you saw that in math form. Sine of x is 1 over cosecant. Cosecant of x 1 over sine. Cosine of x 1 over secant. Secant of x 1 over cosine. Tangent
Para abajo. ¿Cómo debe ser?
1 over cotangent.
Pero así no era para abajo.
Cosine over sine.
De que
1 over tangent. and sine square plus cosine square 1 1 plus cotangent square.
Dios mío, Dios mío. Impresionante.
Okay.
We're going to use only this.
Yeah, all those. Yeah, they were all the ones, like the even out formulas and the functions for the Good. Okay? Listen. Okay with this? Yes. Formulas? Good. Remember how to use them, right?
Yes.
The good thing about this is that the functions that I give you are not going to be that as complex as the one that we saw in Math 4. It will be a little less complex, but still, you need to use the formulas to simplify. Okay? But still, if you had trouble with this in Math 4, no, yeah. Yeah.
Accessories.
No deberían de decir base 4 si vamos a iniciar.
Yo sí les dije que yo no pero pues yo a mis alumnos se les decía, o sea, mate 4 si estos no lo entienden bien, más 5 van a batallar.
A ti no sé.
Es que yo tenía a Damián.
Él tenía para lo.
Ay, sí, para lo
Bueno, ya sabes. Vamos a ver. Can I erase this? Yes. Good. Let's continue. Now you have, for example, number 4, sine of x times cosine of x times secant of x times cosecant of x. Now, listen, in this case, even though you have the sine, cos, etc., but they're multiplying each other. So far, right now, I haven't seen a rule for products. So you cannot apply the product rule yet. We need to simplify. How can I simplify this using the formulas and this? Well, in this case, it would be better. Sine and cosine, try to leave it like that, because they're the simplest functions. Sine and cosine, we leave them. But secant can be changed into what? 1 over cosine and cosecant 1 over sine. So since they're multiplying each other, you can simplify them. Cosine with cosine, sine with sine. So it's just 1.
That's the answer?
No.
Well,
the zero. Derivative of that? 0. Yeah? Good. next one. You have a secant minus tangent times secant plus tangent. Again, you have a product to do something with that. Can I multiply those two binomials? Hmm?
Yes, that is equal to sec square.
Okay.
Ese square, no. Sí.
Por eso es equal to n1.
Okay. But no. The formulas have squares. Those formulas don't have squares. But, can I multiply them?
Sí.
So what do I get? Exactly. Now with this, if I apply this identity here, isolated, f of x equal to 1. So the answer is
0.
0. Okay? Questions?
No.
Very good. Okay. This one? How? By using this one. How? If I isolate from this formula, it's 1 equals to secant squared minus tangent squared. So I pass. So this equal to 1. So same thing. Good. Good. The next 4 rules. The rules for exponential and logarithmic functions. The first one, if you have y equal to e to the x, the natural exponential function, the derivative is the same, e to the x. That's the easiest one. But if the function, number 12, is a to the x, could be any number except 1 or e, then the derivative is a to the x times ln of a. There's a reason for the formula and explain later, but not right now. ln of x, the derivative is 1 over x, and if it's log base a of x, it's going to be 1 over x ln of a denominator. Okay? So those are the 4 exponential and logarithmic functions. What? For what? Examples.
Dice que
Good. So now the examples. The first one, it says y equal to 5 into dx minus ln of x over 2. Do I need to rewrite anything there?
Yes, one
Okay, fine.
you want right.
Yeah, I do want to. One half ln of x. So, derivative. If it's 5 e to the x, we need the 5, and derivative of e to the x is e to the x, so it's the same thing. Minus 1/2 ln of x is, we need the 1/2, the coefficient, times ln of x derivative, 1 over x, yeah? So, to simplify, 5 e to the x minus 1 over 2x, and just multiply the two fractions.
What will that go?
Which one, this? Okay. ln of x derivative is 1 over x. Yeah? Questions?
That's the answer?
Yeah. Direct. Number 2.
No sería de que
Yeah.
los X en la cruz.
No. Remember, when you have your original function, if the variable is in the denominator, you need to rewrite the negative power. With the final answer, you cannot have negative exponents.
Por eso que
So that's why we leave it below. Good. Number 2. Do I need to rewrite? No. F prime of x. 3 to the x derivative?
3 to the x ln of
ln of 3. A is 3, the base. Minus, we need the 2 times log base 4 of x is going to be 1 over x ln of 4. Can I simplify? Well, if you want, you can multiply the 2 times the 1. So it's going to be 3x to the x ln of 3, 2 over x ln of 4. That's the answer. Not yet.
Oh, yeah!
Entonces muy pronto parece que ya van a reprobar. Pronto, faltan más cosas. Más cosas, claro, faltan más cosas.
¿Y más difíciles?
Mira, el problema de esto es de que si esto no lo tienen ahorita y tienen muchos problemas con esto, lo que sigue es que van a tener muchos más problemas.
Profe, tienes que ponerle otra vez
No.
Sí, también.
Yes. Because that's the coefficient. The 1/2 is the coefficient, so really that's the coefficient. But the ln of x will is this. Okay, now for the last one. The last one, number 3 says g of x equal to ln of 3x over 5 square root of x. The rule is only with this right now. So there should be a way to get rid of this complex argument. For that, we're going to use the laws of logarithms. Remember that from our trade? Laws of logarithms. Good, very good. Okay. Yes. You said? Good. Okay. We have three laws for mat 3 that you saw in mat 3. First one, you have ln of a product. You need to expand it. How? It's ln of A plus ln of B. You add the loss. You add the ln. Ln of A divided by B is ln of A minus ln of B. Good. Ln of A to the n power would be n times ln of A. Okay? So we're going to use those rules to do what? To expand this so they become just single logarithmic functions. So we can apply the formula now. But before that, I need to explain.
ln x, no, ln 3x minus
Yes. No, yeah. Subdivision. So yeah, it's going to be ln of 3x minus ln of 5 square root of x. But we haven't finished yet. You still have that 3 and that 5. You need to expand it. Again, ln of 3 plus ln of x. And then, what about this one? Because of this, it's a product because of an addition. But because that minus affects both. So it's going to be minus ln of 5 minus ln of the square root of x. See what I did or not?
Yes.
No? Okay.
Sí, porque están multiplicando.
Because of this, is this rule. Yeah, but you had a minus before. So it's minus ln of 5 minus ln of the square root of x.
Pero si el ln of 5 está multiplicando el ln of x, no es una suma.
Pues pero tiene esos libros que se saltó un paso. O sea, porque ya es que el tiempo desde X y después puede hacer el libro. Pero porque no se utiliza el
You see what I did or not?
O sea, no para usar esa y llegar y
When you have more than x, it just has to be x. Not x squared, not 3x, not 7x, not whatever. Only x. Right now. There will be a different rule later, not right now, that allows to solve this when you have an x.
So, teacher, después de todo eso ya podemos hacer una...
Not yet. We still have the square root.
Lo pasas como
ln of 3 plus of x minus ln of 5 minus 1 half.
y ese ln x ya lo puedes saber.
Más o menos, no tanto.
Okay. In this case, you see what happened from here to here? No? Remember, square root of x is x to the 1/2, right? So I'm applying this one, third one. The 1/2 now is a coefficient because of this law. Now I simplify. Now I need to apply the rules. Why? Because now I have ln of x. So derivative. ln of 3 derivative.
1 over 3.
ln of 3 se convierte en...
Why? Because it's a constant. ln of 3 is a constant. ln of 3 is a number. How do you know that? Well, with the calculator, ln of 3 you have a number. Yeah. The practical way to look at it is that if the function doesn't have an x, it's not a function, it's a number. For example, if I told you e to the square, that's a number, not a function. So the answer will be 0, the derivative. Pay attention, please.
Pero si hay x.
No. This is the first one. Plus
Okay.
ln of x derivative. ln of 5 derivative.
No lo tienes una, ¿verdad?
No, you need to put it. You just put it so you can see. And the last one is 1/2 ln of x is like this one, minus 1 over 2x. Can I simplify a little further? Yeah, the zeros don't matter. And this one can be joined together with common denominator.
Yes.
Can add them. So g prime of x is going to be common denominator 2x. 2x divided by x is 2 times 1 is 2 minus 1. Answer 1 over 2x positive. That's the answer.
Okay, 48.
Entre x, 12. Questions? Yeah, for this week. Okay, the activity, take it out, please. Okay, listen. The activity has 50 exercises and it's going to be due Monday. Now, I'm giving you today the rest of the class, well, the last 10 minutes. And tomorrow's class, do it. Huh? Okay. However, there are some exercises that you're going to cancel from the activity. The ones that have arc, ones with arc, we're going to cancel them for now. Not this one, but we'll see the rules later.
But like, they're ready for Monday.
No. So again, cancel the ones with arc. Cancel them or don't do them. No, I can be done. What's your working, please?
Yeah.
Tampoco puedes hacer.
Pero aquí no tienes que
Y aquí